So I'm very happy to welcome Ralf Hartmann, the new INCOSE president-elect, here with me to talk about systems engineering and especially the future of systems engineering. Welcome, Ralf.
Thank you, Armin.
So maybe as a first question to you, Ralf, so talking a little bit about the origin and the history of systems engineering and also about INCOSE, the organization you will be heading in a year. So in a nutshell, what does systems engineering mean to you?
Okay, so typically I answer this question in a way that I say system engineering is the interdisciplinary approach of developing complex systems along the full life cycle, which means especially that I'm not focusing on the engineering phase alone. I'm considering the full life cycle to production, to usage, and to out of service phase. That is very important. And interdisciplinary, of course, is the other keyword. And if you say history, I mean, the history goes back beyond definitely my age. I think already the pyramids have been built according to system engineering principles, although they were not aware that they did it like this. So system engineering as we know it today, with that term associated also, I think, has been brought in, let's say, beginning first half of the 20th century, when big complex, especially defense program came up, or space exploration programs going to the moon. That's where people recognized there is something new to be done, otherwise we wouldn't be successful.
And how has systems engineering evolved over the last decade? So what have been the major steps?
Well, I think about the decades, at the beginning it was very much about, let's say, trying to understand what the focusing on the life cycle of those development processes, getting that formalized and recognizing that if you involve hundreds of people on a complex project from different disciplines, that there has to be a very rigorous process in documentation and checking at various levels with major reviews. So that is what currently is perceived as the old traditional style of systems engineering. And evolved, I mean, it's clear that that was the starting point. Now it has evolved, of course. The first part of that evolution was, I think, in even accelerating and exaggerating that process. So that means that led to very heavy processes, that led to very standardized processes. In the meantime, we have ISO standards related to system engineering lifecycle processes, which require significant, let's say, formal execution and documentation and so on. That was the first part. Still, this was all still along, let's say, the traditional applications like aerospace and defense. Why now in the meantime? Of course, there are many new industries coming up. And I think the big breakthrough was when, on one hand, some of the applications in other domains like automotive became more complex. So it was not just metal and motor anymore. There were electronics, there was software coming into the game. So that means the spectrum of disciplines became much larger, it was much more complex. And on the other hand, I think we might come to that later on, I mean, the digital means we are having today and the digital transformation, that was the major breakthrough with an evolution which happened and which I think is still in its infancy. There's still a lot to be done at this level. Okay, so
quite some evolution already. So we already touched on that, Ralf, in the beginning. INCOSE, you being its future president. So who is INCOSE and what role does INCOSE play in the systems engineering community?
Okay, so INCOSE is the abbreviation of the International Council on Systems Engineering. And I think the history goes back to, I think, kind of 35 years ago, where in the United States there was originally the National Council on Systems Engineering being created, where representatives from industry, from academia, also from, let's say, governmental customers came together and recognized the, let's say, the essential element system engineering plays in their projects at that time, and it will play in their projects in the future from that perspective. So that's why they created a council on taking care about the collection, definition, and evolution of systems engineering, which then very quickly turned over into the International Council of Systems Engineering. I mean, I myself, I'm now a member since 1996, so quite some time. And so, I think next year we will also celebrate the 33rd International Symposium, annual symposium of INCOSE. So there's quite some history. And I would say INCOSE is the only exclusive organization who deals with the definition, evolution of system engineering, the promotion of system engineering in the world. While of course that is not an exclusive claim, I mean we will come to that probably later, that system engineering is something to be understood and practiced by many others. So that means many other technical disciplines already today recognize the existence of system engineering. They have also built it into their activities to the level they need it. So I mean, this is now broadening up, while I believe, being of course an enthusiastic member of INCOSE, I think, let's say, the guiding force for that is INCOSE today, and I think shall be in the future.
And you have had a professional career before becoming INCOSE's president-elect, I guess. And so how is your professional career actually linked to systems engineering? How did you personally first get in touch with systems engineering and well, basically fell in love with systems engineering?
I think that was quite in the early phase of my at university. So I have an education in electrical engineering, a degree in electrical engineering with an emphasis on automatic control. And sometimes I tend to say automatic control was the first system engineering discipline. But when I was at university, my master thesis, for example, was about robust control of a back axle test stand for lorries. And there already it was about multiple disciplines, electrical, mechanical, and so on. And I had a special project to build a driving robot with a team of people as a project at the university. And there we already split it up into a team who did the mechanical part, including the production in the workshop, the electrical part, the sensors, the software part, the onboard computer, and all this. So there I recognized already the complexity and the importance of the integration of various disciplines. So we were successful with that project. The robot worked at the end, and that was a very super experience I had. And the third one was a presentation I've seen at that time at the university by somebody who talked about applying automatic control to the water quality of the River Rhine. And so that was already, this is not directly a technical problem. And so they were talking about, let's say, having freshwater bassins when the quality is good, then having, let's say, various sensors, opening up those bassins, controlling the flow so that there is really an active control of the quality of the water. And that was the first time when I also recognized, okay, now this as an engineer, this is not about the technical products. This goes far beyond. And if we talk probably later about the system engineering vision and application of system engineering, we will come back to this. So that was the time when I was really already, let's say, interested and excited and inspired. I didn't know at that time that this is an interest in a system engineering perspective, but later on I know that.
So let's talk a little bit also about your new role, being INCOSE's president-elect. What is actually the role of INCOSE's president, and especially of INCOSE's president-elect?
So I think this tandem of president-elect is, let's say, important with, let's say, a very complementary set of responsibilities. So the president-elect, which I am now happy to be since the beginning of this year, is a 2 years duty, and that's somehow the COO, the Chief Operating Officer, if you want, of INCOSE. So I'm very much, let's say, occupied with, let's say, dealing with the processes and the policies of INCOSE, with, let's say, the budgeting and budgeting stuff and those kind of things, but also to engage in major initiatives and special projects. While then, as a president, and currently Marilee Wheaton is the president at this point in time, she's more the outward-looking, overseeing person to communicate to the outside world, to have the relationships to the members and to other organizations, and especially, let's say, represent the system engineering and INCOSE towards the rest of the world.
Mm-hmm. Okay. And what are the key items you have on your agenda for your presidency in the year 2024 and 25?
I mean, this is very much related to the challenges system engineering as a whole has. So that means on one hand, outward looking, we need to make sure that, let's say, taking that example of the quality of the river of the Rhine, I believe still today system engineering is applied very much to technical problems, to technical product development and so on. While I believe system thinking and system approaches can solve much more of the problems we are having and the challenges we are having in the world, like climate, like water quality, like other resources, and to reaching out to that and making sure that system engineering becomes recognized and adapted to help to solve those challenges. This is really what is on my key agenda, to reach out and make the maximum out of system engineering.
Okay, so I think a very interesting program, a very interesting agenda, taking care of really pressing challenges society or human mankind actually, to put it like that, has ahead of it. Maybe Ralf, now let's move on a little more towards what are current and future challenges we do see in industry related to systems engineering. I mean, you already touched on that when talking a little bit about the history and the evolution of systems engineering. For many modern organizations, systems engineering is also a somewhat dusty concept, let's put it like that, which is only relevant for the big aerospace, space programs we know from the past. Why do you think those industries, those modern organizations, should still care about systems engineering?
Now, I think that is really, how to say that, the problem we are having with the legacy understanding of the term system engineering. My interpretation of system engineering is a much wider one. I mean, this, as I said earlier, it's about the integration across all disciplines along the life cycle. Now, we mentioned already that now we are in the middle of the digital transformation and the digital age. So that means now we have new industries coming up which are having a completely different business model. They are developing things much faster. I mean, here the famous term is about agile development, so high speed. And people believe that there's agile on one hand and what you call the dusty system engineering approach on the other hand. I mean, agile is system engineering at its core. I mean, it's about efficient processes and integrating people, and it's just a new concept of, let's say, development process rather than the traditional one, which is used in that dusty area, as you call this. So the right integration between that, let's say, top-level process and then embracing very much many agile streams in modern businesses and industries, that is what industry is about today. Those parts of industry probably don't call it systems engineering, but they do it. So that's the important part. So I'm not preaching that they should convert to using the term system engineering. It's much more about really continuing to do this good stuff in conjunction with, let's say, still the system principles which proved to be successful and important from the past. Mm-hmm.
So you just mentioned the digital transformation, and you already mentioned in one of your earlier answers the software intensity of modern systems. Mm-hmm. What are the big key challenges you see in industries which you believe make systems engineering, or however we want to call it, even more relevant today?
Mm-hmm. No, that's definitely a core challenge. Now, the first thing is what in the system engineering community is always called repeatedly the increased complexity of our systems. But I mean, that is what it is about. Mm-hmm. I mean, if you look to a car today, there are, I don't know, probably 100 microcomputers talking to each other with software and everything else. And compared to a satellite 50 years ago, that was a simple product. So that complexity. Now, on the other hand, we are today also talking what we call the systems of system. So it's not just that there is a car or as a product alone to be considered. It's really the context of having navigation and communication, having telematic systems to communicate with each other, consider the refueling and in the electric area to recharge the batteries. I mean, this is an overall universe and ecosystem which needs to be considered. And if we are not, and this ending up in a big, let's say, mess, if you want, difficult to manage. And difficult to foresee in its consequences if that is not done with a system engineering approach in mind. So that's really the major challenge for system engineering, and at the same time also the major opportunity for all industries to apply system engineering to those kind of problems.
Mm-hmm. And I mean, you now elaborated a bit on those challenges. What will be the impact those challenges will have on systems engineering, on the character of systems engineering, and the way how we will need to do systems engineering in the future? Can you speak a little bit about that?
Yes. So, I mean, the same what is true for the products and the systems we are looking at for development, that is also true for the environment in which we execute, we work, we develop, and we practice systems engineering. So that means in the digital transformation and after the digital transformation, all of that will be model-based. So that means system engineers will not, like in the Dusty example you mentioned at the beginning, will not be about having piles of documents written and read. It is about having consistent formal models of the overall systems, of the breakdown of those systems, of the interfaces. We will be able to simulate that, to have impact analysis of that. And specifically, we will have an integration into all the existing domain models. So if we look to hydraulic, to electrical, to software, all these, and of course CAD, mechanics, they all have this step done years ago into that digital century. Now, system engineering is coming a little bit late and as a fast follower, hopefully, but then it's also about the integration of all those, let's say, model-based approaches from all disciplines into a single integrated set. And then the major challenge is how to orchestrate a development process with all those disciplines in the future along the life cycle. That is what system engineering is not able to do yet. And we need to develop the system engineering competences and chief engineers and leaders who are able to do that.
Interesting. So coming back to the challenges we discussed about, and linking that a bit to how systems engineering will evolve concerning those challenges. What's the biggest contribution you see systems engineering could provide to overcome those future challenges?
I think that biggest contribution is being able to perform that integration. Mm-hmm. So that it's not only looking into one domain with the specialists working in one domain, but looking to this holistically from an overall perspective. So that means if we have, let's say, smart cities is a nice example where it is about, let's say, the human beings and the social aspects of it with respect to the technical aspects of transportation, of resources, of waste management, of, let's say, getting food and water into the city. I mean, this is a very holistic problem. Mm-hmm. And this is, of course, with the mega cities we are having today, people believe that there will be more those mega cities in the future. Most of the population will live in those cities. So system engineering will definitely help to solve and to face those challenges in the future.
Because of its holistic
because of the holistic perspective, because of the interdisciplinary perspective, and because of the methodologies which will help to manage this complexity of those systems coming together in an example of a megacity.
So now let's move on a bit more, talking about the future state of systems engineering, Ralf, here, and the future state of systems engineering to be envisioned. I learned that INCOSE has laid out a systems engineering vision 2035, so a little bit more than 10 years from now on. Why do you think industry should care about this vision?
Yes, so I mean the Vision 35 is a vision which has been created in a series of others which came before. We had a 25 vision, but now what is new in that 35 vision is that it's really anticipated that the challenges are not in technical product development anymore, but in these global systems of systems, in surviving on the planet, in solving those problems, in let's say climate challenges and all of that. This is very strongly laid out in the Vision 2035 as the global mega trends, and and exactly these are the elements which we need to face, and which also drive system engineering not to change, let's say, to change its emphasis, to speak to other domains and to have other approaches to solve those problems, while still there is, of course, the traditional domains of product development which remain to be improved, to be more efficient and so on, but to be embedded with the more holistic approach on the other domains.
So for those among us, Ralf, who haven't had time to read the vision, can you summarize what are the key takeaways of that systems engineering vision 2035?
So one of the major elements, I think, which are new, that we really look very strongly to the mega trends into the future, which are all those societal challenges we are having, as I mentioned earlier in some of the topics. Secondly, that also there is an indication related to some of the digital artifacts we are having. So that means, for example, there's an evolution with respect to the usage of artificial intelligence. So artificial intelligence is part of the systems to be designed, but artificial intelligence is also an element which will help system engineers and other people, let's say, to support them in their activities more efficiently. And so that means all the data analytics and the machine learning and all those modern artifacts we are having in that digital century, they will strongly impact the way system engineering is used and applied, and they will strongly impact the systems which need to be taken care about. Then, of course, there is an element of, let's say, adapting the language of system engineering to non-technical areas. So it needs to be understood by politicians, by social sciences, and by all of those people. So that means from an education perspective, system engineering will be part or shall be part of the education of many of those disciplines. So that means similar to eventually some basic economic skills and some basic project management skills which need to be understood by everybody with an academic education. In the future, system engineering skills need to be part of everybody's education, not just one person who claims to be the system engineer. And spreading that out and also translating that into the languages and the needs of various domains, that is clearly the important message. In addition to be fully model-based and fully digital and so on.
So, I mean, listening to you, what do you think will be the main differentiators of systems engineering as being practiced today compared to a systems engineering you envision to be practiced in the year 2035 then?
I mean, I think in the year 2035 we will be, let's say, the digital transformation will have done the major step forward. So that means also there is in the vision a day in the life of an engineer at that point in time. And I mean, everything what you can see today in science fiction, that will be implemented there. So that means we will have the virtual reality aspect where digital twins, which are built by means of the system engineering modeling methodologies together with the modeling technologies of all the disciplines, will represent the digital twin. We will have virtual reality, augmented reality, all of these elements will be there. And and also the reuse of those models for new developments and new challenges will be in place. In a nutshell, in a second, the analysis of impact of new ideas and new requirements will be there in a nutshell. So that means the speed of, let's say, analyzing something or designing something and also from the design immediately to manufacturing and rolling out, that will increase significantly.
Mm-hmm. And I mean that aspect you're just mentioning is, I would summarize that probably under the headline of speed, so being much more speedy. Are there any other major fields or major areas in systems engineering where you believe we will see a dramatic evolution or a dramatic improvement compared over today's practice?
I think the dramatic evolution will be in the way system engineering is widened up as a discipline, in a way that we are speaking a language that is better understood by everybody participating in the development and usage of those systems. And also, I think that's the major breakthrough we are seeing there.
Yeah, I mean, listening to you, I hear you state, well, it will be systems engineering in real time. Yeah. It will probably leverage heavily artificial intelligence to support decision making. It will widen up to a much broader spectrum, so will go far beyond only engineers. Mm-hmm. And it certainly will make heavy use of models in order to understand the complex interrelationships of the systems which are at consideration, no matter which application domain we're talking about here.
Yep. Absolutely. Okay. And in addition to that, I mean, some people who will listen to our speech here will have some doubt about system engineering in the context of the, let's say, the academic foundation of other disciplines. If you talk about economics or electrical or mechanical or societal sciences and so on, this is all existing, very well defined, while system engineering is not yet there at this stage. So it's more that we have the heuristics and the principles today, but there are definitely a lot of very scientific, mathematically deterministic elements in systems engineering. And I think between now and 35, the whole area of academia and universities and so on will reach a level that we have the theoretical foundation of systems engineering developed and defined in the same way as those other disciplines, so that they also, which will enable the integration of those elements in other educations, as I mentioned before, because I consider that important, that everybody, let's say, has a portion of it and has an education to contribute to the overall systems approach. This is currently difficult because of the lack and maybe also the lack of credibility of system engineering as a formal discipline.
So there needs to be, what you're stating basically, Ralf, is there needs to be a commonly accepted body of knowledge, basically, or scientifically accepted body of knowledge on systems engineering.
Yeah. So we do have a body of knowledge already, a very wide one, which we also have established with the collaboration of other entities, which is on the web. We have a handbook of those, but I think this is still more on at a collection basis and a heuristic basis, rather than a formal theoretically founded scientific, let's say, discipline. And that's really what's now it's absolute. And I mean, it is one, and now is the time to make that really happening, that this is formalized and introduced in that way. And then in 35, nobody will ask the question, what is systems engineering? Because there's this book or this, let's say, this theoretical foundation. It's educated, it's taught at universities, and similar to economics. I think, and that's where, when we have achieved that, I think then we have achieved that element that really also all those, that people believe in it, that there's confidence in it, there's knowledge about it, and then all these benefits we are expecting to meet those challenges we have on our planet, that this can be achieved.
So a lot of work ahead of us, right, in the area of systems engineering. So INCOSE, beyond the Vision 2035, INCOSE has also laid out a future of systems engineering initiative called FUSE. What's the intention of that initiative?
Now, okay, as you said, the vision itself is super ambitious. If you read that, I mean, this is really a super challenge in the future. And of course, INCOSE is a small organization. I mean, it's not that we write this vision and we as INCOSE can implement all the means we are needing there very quickly. So that means the FUSE initiative, the Future of System Engineering, has been created, let's say, is already existing since some time, but has been re-amplified at this point in time towards the Vision 2035, in order to identify now those gaps of what we believe what we will need in the future, how it would look like, what is the status quo, and what are the major elements which need to be developed. And the FUSE initiative will then identify those gaps, create integrated roadmaps towards the future of 35, let's say, what needs to be done there. And then we will orchestrate and inspire and guide the development of all those artifacts together with many other organizations around the world. It's not, I mean, it's not exclusive that INCOSE is in charge of doing that. There will be some contributions by INCOSE directly, but I mean, there are many other organizations who apply elements of systems engineering, who already are, without knowing, on the path to implement some of those artifacts which are outlined in the vision. And we are going to collect that, put them on the roadmap, and somehow make sure that the Vision 35 becomes a self-prophesying let's say, vision.
So you already mentioned that the systems engineering vision 2035 is very ambitious. So is there already any idea what the major stepping stones towards that vision will be?
Yes. So I think the major one, and there are a couple of those. The first one is, as I indicated earlier, is really to create the foundation of system engineering as a discipline. To have the theoretical foundation, but also a, let's say, improved, let's say, practical foundation, so that it's easier to understand also by non-experts in the various other domains. That is one part. The other part is on the methodology part. We mentioned artificial intelligence, machine learning, data analytics, so that system engineering methodologies are embracing those aspects of the digital century in the way forward. As an example. And then the third one is the area of application outreach. So to really push forward and make sure that it is applied and known and contributes to the development of things in non-technical areas. And I mentioned the smart cities or socio-technical systems and all of that. So these are the three major streams also we are using within the FUSE initiative to structure the activities on the way forward.
And what do you consider as being the biggest roadblocks or risks you need to overcome on your road, on your way towards that vision?
I think the biggest roadblock is that to find the right partners. I mean, that is a super big endeavor we are having in front of us. So that means we need to reach out and convince many other organizations, industries, let's say, to recognize that, to follow us on this path towards the implementation of that vision, and also to team up with us, let's say, in creating those necessary artifacts into the future. Because that is the thing. I mean, the few elements which INCOSE on its own power might contribute are not sufficient at all to come close to that vision. So that's the major roadblock we have to face.
And are there any key challenges you see also for INCOSE as an organization?
Yes, I think INCOSE as an organization had a long history of, I mean, we need to understand that INCOSE is a non-profit organization. It's a strongly volunteer-based organization. So that means it is difficult to enforce some activities to be done. So that means that INCOSE needs also to transform to some degree into an organization, let's say, with stronger governance model, also with additional resources, so that we can actively drive those elements without relying on the goodwill of people contributing.
Mm-hmm. And I mean, you also, you already mentioned that and touched on that several times, the broadness, right? You need to reach here, and the partnering you need to reach here. How do you think INCOSE will create the broad visibility and the broad understanding of systems engineering? What are the key levers you envision here?
So the key levers is, again, that we strategically go out into certain industries, into certain organizations, participate also into their events, let's say providing keynotes, having workshops with them, so that we can create a joint understanding of, let's say, what systems engineering might mean for them, and so get them on board and get the buy-in from those organizations. Mm-hmm. And individuals also. Okay. And this means also to overcome, let's say, in some areas that what you call the dusty image of systems engineering, to recognize that everything which is, let's say, life cycle development of systems in an agile manner, of course, is one instantiation of systems engineering processes.
Okay. Maybe let's come to a summary and closing slowly here with you, Ralf. Maybe the last couple of questions. So why should industries start investing in systems engineering now, from your perspective?
Because we are in the middle of, let's say, two trends. The first one is the digital transformation. I think the digital transformation provides a challenge that if you digitalize everything, you just increase the mess you are having. And system engineering, to my view, is the only means to ensure that the various artifacts of digital artifacts we're having in the future somehow interoperate into a reasonable, let's say, process together. And the second one is really that the type of systems we are looking at is so quickly enlarging, as we said, those systems of and smart cities is my favorite example there. Mm-hmm. We will be totally overwhelmed, and the only way of, let's say, having any chance to successfully trying to manage that is having this holistic systems approach. Mm-hmm. And this, when in industry, I think today should recognize that and should invest now very much, without using the term, I mean, but in those system engineering principles at this stage, and getting that ready to be used in the upcoming years.
And any advice you would give to organizations, what these key skill sets are those organizations, or key capabilities are those organizations need to develop?
Well, I mean, there are, let's say, looking to the smaller group of people who are able to help to re-engineer the whole set of processes and the complete set of ways of working. I mean, that is a community which has to be born with a let's say a holistic system approach gene. Mm-hmm. And we need to find those people, and then we have to educate them in addition with experience and with exposure to system problems, and with then the methodological training, let's say, the system engineering theory and foundation will bring in the future to educate them there. So this is really, and then of course, if I say interdisciplinary, it means also these people don't have just technical skills. They have to have social skills, communication skills. They need to understand how legal aspects, sustainability aspects, let's say, we will have in the digital century those elements of, let's say, the security threats we are having. I mean, all of that needs to be understood by those people. So that means the skill set is, let's say, people who have an understanding about an appreciation of the width of let's say, areas and disciplines which need to be there taken into account.
And why do you think, Ralf, companies should join and contribute INCOSE and the Future of Systems Engineering initiative?
Yeah, because I mean, that's in order to influence the way forward. I mean, The communities which are working on this, on the way forward, of course they are coming from their own background, their own interpretation of what those problems might be, their understanding of certain application areas. So that means industry shall participate to make sure that their viewpoint, that their systems, the needs of their customers, their legal environment and business environment is correctly considered to drive forward, let's say, the elements of system engineering in the future. Otherwise you will get an automotive-based systems engineering approach in the future to be applied on healthcare systems. And that will not work. Healthcare and others have to be part of that journey, because it's not that one size fits all. The principles fit all, but then they have to be instantiated rightly to the various challenges and domains.
Okay. And maybe as a closing statement, in a nutshell, what would you tell a chief technical officer or an engineering executive how systems engineering will look and feel like in the year 2035?
I think that is, we had that earlier. That is really about the fact that there are integrated digital twins of the whole ecosystem of what the company is looking at. And that the integration of that is really not easy to manage, because of the various disciplines are not on their own able to achieve that. And then, and secondly, then, this will give them at this point in time the speed, the agility, and the flexibility of the new challenges with respect to legal and other constraints which will come at this point in time.
Okay. Thank you very much, Ralf. That was a very interesting and fascinating talk, and we're really much looking forward to future talks we hopefully will have on the topic of systems engineering and the future of systems engineering. Thank you very much for being with us.
Thank you, Armin, for inviting me to that. It was a pleasure. And of course, not talking about it will not help us to go forward.
So, and if you want to know more and learn more about the future of systems engineering, the Systems Engineering Vision 2035, then feel free to reach out to us and contact us.